Okay, example 3. A biologist tracks the population of a new species of frog over several years. So we're given a table of values over here. We've got at year 0 to start, we've got 400 frogs. After a year, there's 480 frogs. After 2 years, there's 576 frogs. From the table, determine the equation that models the frog's population growth and determine the number of years before the population triples. Okay, so from here we can see it tells us growth, and we can see it's a growth equation because, or growth function, because it's increasing. The number of frogs is increasing over time. So all of our equations are going to have the formula ab to the power of x, where a is our initial amount, and b is our growth or decay factor. Okay, so to figure out how much we are increasing by, I'm going to take my, I'm going to look at my y values, and I'm going to take each number and divide it by the one before. So 480 divided by 400 gives us 1.2. Then, sorry, it's a bit tight here, 576 divided by 480 is 1.2. 691 divided by 576 is, surprise, surprise, 1.2. That pattern is going to continue, and each time we divide, we're going to get 1.2. So that is our growth factor. Our b value is 1.2. Our initial amount is 400 frogs. So my equation, and actually I should have put a t over here if I have a t right there, is a, which is 400, times b, which is 1.2, to the power of t, which is time. So there's my equation. We want to know how the number of years before the population triples. So I have my equation. We want to know the number of years before the population triples. So if I'm looking for t, and our population tripled, which means our final amount after the number of, our final amount is our initial amount tripled, which is times 3. So we want to know how many years did it take for the population of frogs to grow to 1,200. Okay, so I mean, I can continue this table over here, or I can find it algebraically, which is the preferred method. So I know that a of t is 1,200 equals my initial amount. So I'm just plugging this value right there in my formula, or in my equation, to the power of t. Now I'm solving for t. So to solve for an exponent, I'm going to divide both sides by 400, which gives me 300 equals 1.2 t. Okay, now this is what I explained in example 1. T is going to equal log answer divided by log base. So that means t equals log, the answer is 300, and my base is 1.2. So using my calculator, log 300 divided by log 1.2 is 31.2. So it would take 31 years for the population to triple. Okay. And that's it. The filled in version is posted. Do your homework.